Hello everyone, my name is Mark. Welcome to my Calc 3 videos, and today I would like to talk about partial derivatives with you. And to start with, I would like to discuss the graphical meaning of the partial derivatives, right? So for example, I am climbing a mountain, right, or surfing, right? So where my elevation is the height, which is z in the function of x and y, e is the positive x-axis, and north is my positive y-axis. So what does fx and fy and their derivatives mean, right? So I think so. If I'm heading east if my positive x-axis is in the east direction, that means fx is how fast I am traveling. How fast is my height increasing in the east direction, right? So that's basically what you have learned in Calc 1 and Calc 2 is derivative is the rate of change, right? So in this case, it's the rate of change of my height along the east direction. Same thing for the y, right? That's in the north direction. And then the derivatives mean like we have fx, x, fy, y, right? So let's talk about the first two. So, right, so I think in Calc 1 and Calc 2, we have also learned that the second derivative is the curvature, right? So you can kind of think about these two quantities as the curvature of your changing elevation. So we're gonna briefly mention the fxy and fyy or fyx. These two quantities, most of the times, they are equal to each other, but they are not always. Okay, often, but not always. I'm gonna touch base on this, and then we will learn about this much later in chapter 17. But right now, just remember this: often, but not always equal. So now we kind of have a basic understanding of the partial derivatives. So how does it resemble regular derivatives, right? Right. So when in Calc 1 and Calc 2, when we perform the derivatives, we only have one variable. We treat everything else as a constant, right? And that is the exact same thing here. When we compute the partial derivatives with respect to x, right, we treat y as well as all other variables as a constant. Variables. Right, this is how you compute partial derivatives. That's the same thing for Calc 1 and Calc 2, and it's the exact same thing in Calc 3. Okay, so let's talk about the first question. If the function of this function, right, is given as such, and I want you to compute the partial derivatives of fxy. So this is from exam 1 for 2019. Let me go ahead and open my one pagers. So let me go ahead and stack them up as usual, right? So this is a partial derivatives question, and you can tell that from the partial derivatives notations in the question statement, right? The one I underlined in pink. So something to note about this notation is that there are two different types of notations. So what you see here is fxy, so that means we will take the partial derivatives with respect to x first and then y second. But Newtonian notation is backwards, okay? It's from right to left. So you take the partial derivatives with respect to x first and then y second. So you're reading from the right to left. Okay. The first step is just to go ahead and find your first level of partial derivatives, right? So first derivative is just going to be, oh, come on. This 1 second. What's going on? Okay. I have resolved my technical problems. So first step is just going to be fx fx equals to 2. You have, let's say, your power rule, right? So x squared plus y 4 plus 2, right? Negative first. And then you have the partial derivative with respect to x. So that's 2x. You're using a chain rule here. Don't forget your basic calculus rules, skills. And the second step is going to be find your the second level derivatives, right? So fxy is just going to be negative 1, 2x, and then that's your power rule again, x squared plus y to the 4th plus 2, negative 2, right? And then you have your chain rule this time with respect to y, so that's 4y cubic, and that's your fxy, and then you can go ahead and evaluate at, or I just call them right here, right? So 3, right? Plug in, evaluate. So that's your step 3. fxy at 2, 1 equals to negative 1, 2 times 2, 2 squared plus 1 to the 4th plus 2, negative 2 times 4 times 1 cubic. This is 7, so 7 to the negative 2 power. So this will give you 1 over 49, and then the rest will give us negative 16. So the correct answer for this question is D. Okay. So that's pretty easy, right? So you just basically do the same thing you have learned in Calc 1, and then you apply it for the multiple functions of multiple variables. Another interesting question I would like to bring up is here. So you can see that we have another problem. Suppose the graph of z intersect with the plane x0 along the curve z equals to something something. And then what is the g of y at 0 and 2? So I want you to pause this video and fully understand this question before you continue. So I assume you have thought about it, and then let's approach this question carefully, because this is interesting, right? So we don't really know what g is. So how can we possibly compute its partial derivatives? Right? Think about that. Right? Well, g is missing in this question. So the correct approach to the solution is, if you read this question carefully, you would realize z. I'm gonna put this in a new page. Z of, let me go ahead and change the orientation as well. So this is your problem, right? So z of y cubed plus 2y squared plus 1 is actually a section of g of xy. Okay? We can confirm this since there is no x terms in z, okay? Because it's intersecting the plane at x equals 0, right? Of course, x will be missing, right? X equals 0, and then there's no x term here. Of course, x will be missing. So what this means is g of xy equals to the same thing of z. I mean, that's, so even though this question has already given that z equals to g of xy, I want you to have an understanding of what this question is about before you can compute the math, right? And then g equals to this at x equal to 0, right? At this particular instance, x equals to 0, this is the expression of g. So then you can go ahead and compute the partial derivatives. So that's 3y squared plus 4y, because g is actually a function itself, right? And then z is actually the function of g. So, and then g of y at 0 and 2, right? Again, we can confirm this by x equal to 0, right? We don't necessarily have to have the full expression of the g of y, but it's useful enough at this particular instant that x equal to 0. This will give us 20. So the correct answer is E. So, and that is all I have for you on 15.3 partial derivatives. I hope this concept is intuitive enough, simple enough for you to understand, and we will be continuing to use this skills further down the line of Calc 3. So thank you very much for watching. I hope you learned something. I hope you liked my videos, and I will see you in the next one.